Okay, so in this question, we are given with function f of 3x plus 1 is 6x minus 5, g of x is x plus 4 by 3, and f of g inverse x is 3. And using those three information, we need to get the value for x. So, first of all, what we are supposed to do is that we need to change that input 3x plus 1 is simple input as x. So for that, let's start with function f of 3x plus 1. So here, f of 3x plus 1 is 6x minus 5. It might be that your output of this function maybe is a quadratic expression or maybe linear. So what we need to do that it should, whatever method we are going to apply, it should be applicable to both type of function. So what we do, we'll assume that 3x plus 1 equals to y, and we'll calculate the value of function. We will calculate the value for x, which gives us 3x equals to y minus 1, and ultimately x is y minus 1 by 3. So now we'll use that in our given function. So it can be written as f of y, because we assumed that 3x plus 1 is y, and equal to 6x minus 5. So here 6, x is our y minus 1 by 3, and then minus 5. So if we cancel out the expression, cancel out and then write it in simplest form. So 3 1 is 3 and 3 2 is 6. So which ultimately gives us f of y equals to 2y minus 1. Sorry, not minus 1. It should be minus 2 and then minus 5 and finally 2y minus 7. So that gives us an idea about how function f looks like. So that is your function f. Though its input is y, so don't get confused. Here y is not the range. Here y is the input. So now let's move on to its second part, in which we'll be using function g of x to get the value of g inverse x. So our g of x is given as x plus 4 by 3. So let's take that one. G of x equals to x plus 4 by 3. To evaluate the inverse, we need to change the role of input and range, means output. So let the output is a simple value y, and now we need to interchange x and y. So on interchanging x and y, we get. So we'll be getting it as y plus 4 by 3 equals to x. Let's solve it, which gives us y plus 4 equals to 3x, or y equals to 3x minus 4, and here y is going to behave as g inverse x. So our g inverse x is 3x minus 4. So we got the value for f of x, means f of y, means function f, and then g inverse x. Now we'll combine both of them to get the value of x. So now we are in our final step. So now FOG inverse x is 3. So if you remember the calculated function f of x or f of we calculated it as not as a x, we calculated it as a f of y, and we obtained it as 2x minus 7. So we'll be using this one. You can refer after that how we calculated f of y. Let me correct it. It should be f of y here. So f of y minus 7, not x. So f of y we calculated it as a 2y7. It means that if we take y as an input, then output is going to be 2y minus 7. Now you need to understand what is actually f of g inverse x. F of g inverse x is a function. It's a composite function in which g inverse x is a input and f is a function. Remember this. F O G inverse x, it means that G inverse x is input and F is the function in which you are going to use that input. So let's use that function f of y and express our expression in terms of G inverse x. So it gives us 2 G inverse x minus 7 equals to 3. Now we have G inverse x. Now again recall what we have calculated for G inverse x. So we calculated our G inverse x is 3x minus 4. So we'll be using that function G inverse x. We'll be using this value. So as per this, we can write our expression as 2 times of 3x minus 4 minus 7 equals to 3. Let's open the bracket, which gives us 6x minus 8 minus 7 equals to 3, and it gives us 6x equals to 3 minus 7 and minus 8. When we transfer it to RHS, it becomes plus, and it ultimately gives us 3 plus 7 10, 10 plus 8, it gives us 18. Now let's cancel out 6 and 18. So it can be cancelled. 6 1 is 6, 6 3 is 18, and finally we'll be getting our final value is x equals to 3. Now we are done. So that's all for this question.